by migrating to the cooler clouds in the upper atmosphere. Here, though, they may have faced an even greater challenge for survival.
The only real problem with the clouds of Venus is that it is extremely acidic. But we keep finding more and more extreme organisms on Earth that love living in sulfuric acid.
Deep on our ocean floors, volcanic eruptions blast out sulfurous fluids, creating a superheated, highly acidic environment. Yet even here, life abounds. Colonizing Venus is not an option. We must head further out, toward the last of the solar system's inner rocky worlds. This time, it's one that scientists think that we may just stand a chance of living on. But the challenges facing would-be settlers go beyond anything we've ever seen on Earth. Mercury and Venus can never support human life on any large scale. We pass Earth and move deeper into the solar system. The next planet is Mars. Could we one day settle here? Mars is the one world that most resembles our own. A Martian day is almost the same length as ours. Mars has mountains, deserts, and gaping canyons, cut in the distant past by running water. Traces of that water may still be locked beneath the surface, but to reach it, we would have to face an ancient danger: radiation. 5 billion years ago, when our sun was born, it blasted high-speed, energetic solar radiation out across the whole solar system. And it's still doing it today. Without some sort of protection, we could not possibly survive. We were lucky. Our world developed a magnetic field. This shield deflects deadly solar radiation away from the surface. But Mars has no magnetic field, and that means no protection. Over many millennia, the solar radiation ripped the atmosphere from the planet. Mars's water boiled, and most of it evaporated into space. The surface became a barren desert. For any future human visitors to the Red Planet, solar radiation will be a deadly hazard. Even with the protection of a spacesuit, the radiation can still penetrate. It tears through the body, bombarding and killing living cells, destroying DNA. If humans are to live and work on Mars's surface, we'll need some serious protection. So scientists are developing drugs. Astronauts would take these specially designed enzymes to mop up the radiation. Martian homes would need shielding too. Scientists have developed a special form of polyethylene plastic, lighter and stronger than metallic shielding, yet just as effective. The plan is to build it into the structure of Mars habitats, protecting the occupants. With this advanced technology, humans could one day consider populating Mars. But there's another hazard to overcome. After the radiation stripped the water from the surface, the planet was left covered with dry iron oxide dust. Meet the sandstorm, Martian style. These mini twisters are babies, dust devils just powerful enough to suck dust up into the atmosphere. The problem is, what happens next? Professor Ron Greeley has been studying atmospheric activity on Mars for over 30 years, knowledge vital for any human expedition to the Red Planet. Greeley uses a fan and frozen nitrogen vapor to recreate these twisters in the lab. They form when the sun heats the surface, causing a pocket of hot gas to suddenly rise, spinning through cooler air above. It sucks up fine iron oxide dust and punches it high into the Martian atmosphere.
The dust devils range in size from about a yard across to features that are as large as a football field in diameter. These can be quite large.
That dust has to go somewhere. Greeley believes the mini-twisters could trigger much bigger storms.
We do, in fact, see local dust storms that grow to global proportions. Clusters of individual dust storms that eventually merge. The entire planet is enveloped in dust, and we can't even see the surface through that dust.
But it's not just dust devils that can trigger trouble on a global scale. Wind blowing across the surface can kick up dust into the atmosphere, building into an overwhelming storm. This also happens on Earth. Satellites photographed a storm raging across the Sahara Desert in Africa, revealing its enormous size. The similarity with the storm on Mars is striking, and that much dust is going to cause problems.
When humans go to Mars, they have to be concerned about the infiltration of this very fine dust. It's sort of like baking flour, if you will, very, very fine grained.
The dust is so fine that even the slightest wind can blow it anywhere, clogging up machinery and air supplies.
Not only is the dust likely to get into every nook and cranny, but there are also properties of the dust that may pose a hazard. One of the considerations are the electrostatic charging effects. When little tiny grains bang together, electrical charges are built up.
Much like shuffling your feet on a carpet, the rubbing action between the grains of dust creates enormous static electricity. Up to 20,000 volts can spark between the dust particles. This could destroy electronics and life support systems.
When we think about the eventual human presence on Mars, we have to understand the dust regime, we have to understand the electrostatic effects, all related to wind-blown particles.
Perhaps one day we will conquer Mars's harsh environment, but this is not a world that would ever feel like home. We leave Mars and push on out toward the supersized worlds of the outer solar system, the gas giants. These offer new and even more extreme challenges in our quest for another home. First up is Jupiter. Jupiter is a mysterious world so vast that 1,300 Earth-sized planets could fit inside it. It's entirely made of gas. It has no solid surface at all. Its upper layers are a mass of swirling counter-rotating clouds. This is a planet racked with storms and high-speed winds. Professor Fran Bagenal has spent a lifetime studying the atmospheres and environments of Jupiter and its moons.
Jupiter is spinning extremely fast. It rotates every 10 hours. And so rotation is very important and drives those east-west winds that produce the belts and the zones, those stripes across the planet.
Jupiter's high-speed spin generates horizontal bands of clouds that wrap around the planet like a belt. When these cloud bands collide, they create massive storms. The biggest of these is the Great Red Spot, the largest storm in the solar system. As we approach, the scale becomes clear. It's 3 times the diameter of Earth.